Hi, good evening all. Today, let us see some problems related on admittances. Before solving this problem, you need to know how the admittances are connected in series connection as well as the parallel connection. Now, our target is to find out y equivalent, where y1 is the admittance of the first branch, where y2 is the admittance of the another branch. So how to find out y equivalent is, so now it is very tough for us to understand, or we need to find out y equivalent. So for that I'm going to convert this y into some, this is one branch, this is another branch, and now first I'm going to find out r equivalent between these two branches. Okay, so this is 1 by, I mean y1, I'm writing it as 1 by y1, the units are ohms. This is 1 by y2, the units are ohms. Now you can see here the current enters this branch and current flows. These are the two resistors connected in series connection. So here these are the two resistors which are connected in series connection. Whenever two resistors are connected in series connection, the R equivalent is, what is the R equivalent? So R equivalent is, generally R equivalent is equal to 1 by y1 plus 1 by y2. So now from here I can write down R equivalent is equal to, take the LCM, is y1 y2. So if you take here you will get y1 y2. So this term is y2 plus y1. But we don't want R equivalent, we want y equivalent. So I'm going to write down y equivalent is equal to 1 by R equivalent, where R equivalent here is y2 plus y1 divided by y1 y2. So this will come to the numerator. So therefore the formula here you are going to get y1 y2 divided by y1 plus y2. So therefore the formula of y equivalent is equal to product of y1 and y2 divided by sum of y1 plus y2 is the value of the value of y equivalent when two admittances are connected in series. Generally the formula for when two resistors are connected in series is r1 plus r2, but here you are going to get the formula of resistors connected in parallel. Why? Because everything is reversed here. So this is the formula of y equivalent when two admittances are connected in series connection. Now let us try to find out y equivalent when two admittances are connected in parallel. Okay, so for this what I'm going to do is, so I'm going to draw an circuit. This is circuit 1, this is circuit 2. So here I'm going to write down 1 by y2, the units are ohms. This is 1 by y1, the units are ohms, and here we are going to get y equivalent. Therefore we need to find out y equivalent. So rather than finding y equivalent, let's try to find out r equivalent, which is very easy. The two resistors are connected in parallel. So therefore, when two resistors are connected in parallel, what is the formula of r equivalent is r1 into r2. What is r1? 1 by y1. So r1 into r2 divided by r1 plus r2. So from here, what I can write down is, common term is y1 y2 divided by, so here the LCM term is y1 y2, this is y2 plus y1. So y1 y2 will get cancelled. So here we are going to get 1 by y1 plus y2. Here we got the value of r equivalent, but we require the value of y equivalent. So y equivalent is equal to 1 by r equivalent, that is equal to 1 by y1 plus y2. So when you bring, so this value is 1 divided by 1 by y1 when it comes to the numerator. So therefore y equivalent is nothing but y1 plus y2. So the simple formula to understand, whenever two admittances are connected in parallel, automatically you have to use the formula of a sum of admittances. Okay, so the sum of additions. So this is the formula when two admittances are connected in series connection. This is the formula when two admittances are connected in parallel. So this plays a major role when we are solving multiple problems. So now let us try to find out whenever an admittance is there, short circuit, what will happen. So here we want to find out y equivalent. So this is the value of y1, and here you are having one short circuit branch. Why? Because generally in y parameters will perform short circuit. So now here it is short circuited means r is equal to 0. What is the value of y2 here? So here it is nothing but 1 by 0. This is nothing but infinity. Now y2 is infinity. When two admittances are connected in parallel, okay, the formula is we have y1 plus y2, but we have y1 plus y2 value is how much now? Infinity. Okay, so y equivalent is infinity. So y equivalent is infinity means what is r equivalent of the resultant? 1 by r equivalent. Okay, so 1 by, so we are going to find out. So this is infinity. So automatically R equivalent should be 0. Okay. So here it's offering, therefore Y equivalent is nothing but for this circuit is nothing but an short circuit. So this is nothing but the Y equivalent is 0 is indirectly R is 0. So indirectly whenever the current comes here, the current in this branch is 0. Is like it is offering high resistance, therefore current flows only in this branch. Okay, therefore current flows only in this branch. So current doesn't flow in this branch, the current flows only in this branch. So therefore the resultant is nothing but this is with resistance R is equal to 0 or Y equivalent. So whenever you have an admittance parallel to an short circuit, this is directly is equal to an short circuit. Meaning is that the current in this branch becomes 0. If the current in the branch becomes 0, automatically the current doesn't flows. It acts like an short circuit. This is called Y equivalent. You may get confused. Now what is this R equal to y equivalent is equal to infinity. This is the meaning here. Okay. So hope you understood the formula. Let's try to have a small revision. When two admittances are connected in series, the formula you have to employ is y1 into y2 divided by y1 plus y2. When two admittances are connected in series, parallel, the formula is y1 plus y2. So whenever an admittance is there in parallel to short circuit, is also equal to an short circuit, which means that the current doesn't flow in the resistive branch. Why? Because this resistive branch offers high resistance. So whenever I is equal to V by R, whenever it offers high resistance, the current doesn't flow. Okay, so therefore the current flows only in this branch. That's why meaning of Y equivalent. Hope you understood. So the importance of this we'll see in the next video and next problems. Hope if you like the video, like, please give a like and please share with your friends. And if you have any doubts, let me know in the comment section. And if you're watching for the first time, please subscribe the channel. This is a channel for the benefit of the students. We'll meet in the next video. Thank you for watching. Yours obediently wrong.